Welcome students to GS Maths once again. Continuing my chapter number inverse trigonometric functions. Today I am going to solve few problem sums based on the properties discussed in the previous lecture, that is lecture number 2. Hope you have gone through my lectures on this chapter inverse trigonometric functions. I have written the first question, prove that tan inverse under root x equals to half cos inverse of 1 minus x upon 1 plus x. Now today the sums will be based on the properties which were discussed in the previous lecture. Now this is half cos inverse 1 minus x upon 1 plus x. Half cos inverse, I can write like this, 1 minus under root x square upon 1 plus under root x square. Right? Now this is cos inverse 1 minus x square upon 1 plus x square. Half as such, this part can be written as 2 tan inverse x. 2 with 2 goes, I get the left hand side, tan inverse under root x. This is your left hand side. I took the right hand side, used the property कौन सी कि tan inverse of x is cos inverse 1 minus x square upon 1 plus x square. This property I have used over here, that is cos inverse 1 minus x square upon 1 plus x square. In place of x is under root x. So what I will write, it's 2 tan inverse under root x. 2 with 2 cancels, tan inverse under root x, which is equal to left hand side. I get the answer. Now the second sum I will write down. Just go through the properties, just go through the fundamental formulas which we will use over here in solving the problems. Now next question is question number 2. If x, y, z they belong to x, y, z, they belong to the interval minus 1 to 1 such that sine inverse x plus sine inverse y plus sine inverse z is 3 pi by 2, right? And it's given, find the value of x raised to power 2006, x raised to power 2007, x raised to power 2008 minus 9 upon x raised to power 2006, y raised to power 2007 plus z raised to power 2008. Now sine inverse x plus sine inverse y plus sine inverse z is 3 pi by 2. This is given to us. Let me write down once again. Sine inverse x plus sine inverse y plus sine inverse z is 3 pi by 2. Right? Now we know कि जो sin x की minimum value है, that is minus 1, and the maximum value is positive 1. So I can break this as pi by 2 plus pi by 2 plus pi by 2, right? We can write it as, since it's an inverse function, so we can write it as minus pi by 2 to positive pi by 2. This is the minimum value of sine inverse x is minus pi by 2 and the maximum value of sine inverse x is positive pi by 2. This is sine inverse x plus sine inverse y plus sine inverse z. This is equal to pi by 2 plus pi by 2 plus pi by 2, which means that sine inverse x is equal to pi by 2, that is x equals to 1. Similarly, y is also equal to 1, z is also equal to 1. Now I have to find the value of this expression. This is x raised to power 2006 it's 1 raised to power 2006, it's 1. X raised to power, it's again 1, it's again 1. Minus 9 upon 1 plus 1 plus 1. That is 3 minus 9 upon 3. Answer is 0. That is the value of sine inverse x, minimum value minus pi by 2, maximum value positive pi by 2. So I proved this 3 pi by 2 into pi by 2 plus pi by 2 plus pi by 2. Sine inverse x equals to pi by 2, so x equals to 1. Similarly, sine inverse y equals to pi by 2, y equals to 1. Sine inverse z equals to pi by 2, so z equals to 1. Just put the values, we get the required answer. This is x raised to power this, x raised to power this, x raised to power this. This is 1 raised to power minus 9 upon x is 1 raised to power 2006. Y raised to power, this is z raised to power. You get 3 minus 9 by 3, that is 3. So 3 minus 3 equals to 0. Now I will solve another sum for you. You have to go through the properties I am again and again repeatedly saying, right? Blame in yourself that you can solve the sums, you can solve the problem sums, but you have to remember the properties. Now question number 3 is coming up. Question number 3 is prove that, we have to prove this, prove that cot inverse under root 1 plus sin x plus under root 1 minus sin x upon under root of 1 plus sin x minus 1 minus sin x, this is equal to x by 2, given that x value lies between 0 and pi by 2. Now take the left hand side, it's cot inverse, this is 1 plus sin x under root. I can write this as cos x by 2, cos square x by 2 plus sin square x by 2. In place of 1 I can write this plus sin x is 2 sin x by 2 cos x by 2 plus this can again be written as the same cos square plus sin square minus 2 sin cos divided by cos square sin square, it's plus sin x, 2 sin x by 2 cos x by 2 minus 1 minus cos square x by 2 sin square x by 2 minus 2 sin x by 2 cos x by 2. Now this becomes cot inverse. I can write this as perfect square of cos x by 2 plus sin x by 2 whole square. This square and under root goes. I am left out with this. Plus again this comes out to be cos x by 2 minus sin x by 2. Its whole square, under root cancels. I am left with this only. Divided by cos x by 2 plus sin x by 2 minus cos x by 2 minus sin x by 2. Now here a question can arise, okay, why I haven't written sin square x by 2 plus cos square x by 2? Because of this thing. Because my angle is x by 2. I am given 0 less than x less than pi by 2. My angle is x by 2. 0 less than x by 2 divide pi by 4. Dividing the whole of the inequality with 2. 0 divided by 2 is 0. It's x by 2. It's pi by 4. Now x by 2 lies in the interval 0 to pi by 4. In 0 to pi by 4, cos x by 2 is greater than sin x by 2. That's why I have written intentionally cos x by 2 plus sin x by 2. It doesn't matter in it because there is a plus sign. But here when I take the negative, that is cos x by 2 minus sin x by 2, my angle was x by 2. X by 2. Interval given was 0 less than x less than pi by 2. My interval being x, angle being x by 2. So what I did? 0, x by 2 less than pi by 4. My interval is 0 to pi by 4. And in 0 to pi by 4, cos x by 2 is greater than sin x by 2. Now I can solve it. This sin x by 2 cancels. Cot inverse, I am left with 2 cos x by 2 divided by cos x by 2 cancels. I am left with 2 sin x by 2. This 2 with 2 goes. That is cot inverse. Cot of x by 2 is left. Cot and cot inverse cancels. The answer is x by 2, which is equal to your right hand side. Here I use the concept 1 plus sin x. Again trigonometric formula that 1 plus sin x can be written like this: cos x by 2 plus sin x by 2 whole square. And 1 minus sin x can be written as cos x by 2 minus sin x by 2 whole square. It could have been sin x by 2 minus cos x by 2. It will give you the same result. But my interval given was 0 less than x less than pi by 2. So what I have to do is I have to check out for the interval of x by 2. X by 2 belongs to 0 comma pi by 4. So 0 to pi by 4, I know cos x by 2 is greater than sin x by 2. That's why we have to write it as cos x by 2 minus sin x by 2. Solve it, I get the right hand side, that is x by 2. Hope the concept is clear. This concept is clear that when the angle lies between 0 and pi by 4, in that interval cos x is greater than sin x. And pi by 4 to 90 degree, sin x is greater than cos x. Next question. Question number 4. Question number 4. Question is prove that cos tan inverse sine of cot inverse x this is equal to x square plus 1 upon x square plus 2 under the root. Now here I am again going to use this cot inverse x. This is cot inverse x. It is base upon the perpendicular. I can write cot inverse x as cot inverse x over 1. This is base upon perpendicular. Now I have to find this. This will be 1 plus x here. This is x. So I can write this as cos tan inverse sine. Cot inverse x is equal to sine inverse of perpendicular over hypotenuse. Sine inverse of perpendicular over hypotenuse. This cancels out. I am left with cos tan inverse 1 upon under root 1 plus x square. This. Now I have to change this into cos inverse. Again solve the right angle triangle. This is tan inverse of perpendicular upon base. Perpendicular upon base. So this hypotenuse comes out to be 1 square plus this square. It is 2 plus x square. Now change this into cos. This is cos inverse base upon hypotenuse. Base is 1 plus x square upon hypotenuse, that is x square plus 2. Cos inverse goes. I am left with 1 plus x square upon 2 plus x square under the root, which is equal to your right hand side. Here I have used the concept which I discussed in my previous lecture, that cot inverse base upon perpendicular is equal to sine inverse perpendicular over hypotenuse, tan inverse perpendicular over base is equal to cos inverse base over hypotenuse. I've used this concept. I changed cot inverse x into sine inverse. I've changed tan inverse of x into cos inverse. Then cancel out, I get the required answer, x square plus 1 upon x square plus 2 under the root. Now, next sum is, let me repair this like this. Now, prove that sine inverse 4 upon 5 plus sine inverse 5 by 13 plus sine inverse 16 by 65. This is equal to pi by 2. Now I will use this formula, sine inverse x plus sine inverse y. This is equal to sine inverse x under root 1 minus y square plus y under root 1 minus x square. I will use this property of sine inverse x plus sine inverse y. Now sine inverse x plus sine inverse y, this is sine inverse, I will group the first two terms, sine inverse 4 by 5 plus sine inverse 5 by 13 plus sine inverse 16 by 65. Now I will group these two terms. So I will apply this formula, sine inverse x, right, into 1 minus y square, 1 minus 25 by 169 plus 5 by 13 into under root of 1 minus x square, 1 minus 16 by 25 plus sine inverse 16 by 65. Now sine inverse 169 minus 24 is 144. 144 by 169 is 12 upon 13. 4 by 5, 12 upon 13 plus 5 by 13 multiplied by 9 by 25, 3 by 5 plus sine inverse 16 by 65. Just solve it. I get sine inverse 48 plus 15, 63 by 65 plus sine inverse 16 by 65. Now again apply the same formula, that is sine inverse x plus sine inverse y equals to sine inverse x into 1 minus y square under the root plus y times under root 1 minus x square. Again applying this, I get sine inverse 63 by 65 multiplied by under root of 1 minus 256 by 65. Rather, I will write down as 16 upon 65 square plus 16 by 65 into under root of 1 minus 63 upon 65 square. Now when we solve this, we will get sine inverse, this will be 1. When we solve this, the answer will be 1. And I can write 1 as sine inverse sine pi by 2. This sine and sine inverse goes, pi by 2 is the right hand side. I haven't solved this because in order to save your time and my time also, when you solve it, you try, that is 65 square minus 16 square upon 65 into this, and this is 1. So I can write 1 as sine inverse, 1 as sine pi by 2, sine and sine inverse cancels out, and left out with the right hand side. Hope you have understood the concept, but again I am repeating, you should remember the properties of inverse trigonometric functions so that they can be applied in the problem sums. Now my next question is again a very important question. Question is, listen, prove that 9 upon 9 pi by 8 minus 9 by 4 sine inverse 1 by 3, this is equal to 9 by 4 sine inverse 2 under root 2 by 3. This was in the board exam this year, that is CBSE board exam this year. Now take the left hand side, 9 upon 8 pi, 9 upon 4 sine inverse 1 by 3. Now 9 by 4 is common, I get pi by 2 minus sine inverse 1 upon 3. Now I again use the property that sine inverse x plus cos inverse x is pi by 2, or cos inverse x is pi by 2 minus sine inverse x. Now it's 9 by 4, pi by 2 minus sine inverse x is cos inverse x. That is cos inverse of x की value 1 by 3. Thus, now just we can write cos inverse 1 by 3 as, again I will use this, the cos inverse of base upon hypotenuse is sine inverse of perpendicular over hypotenuse. Now solve this, draw a right angle triangle. This is given as cos inverse base upon hypotenuse. Base upon hypotenuse, I get this as 9 minus 1, 8, that is 2 under root 2. So sine inverse will be sine inverse perpendicular upon hypotenuse. This is your right hand side. I use the property is sine inverse x plus cos inverse x is equal to pi by 2, or cos inverse x equals to pi by 2 minus sine inverse x. And cos inverse base upon hypotenuse is equal to sine inverse perpendicular over hypotenuse. I have used over here, that is pi by 2 minus sine inverse 1 by 3 can be written like this. Cos inverse 1 by 3 can be changed into sine inverse 2 under root 2 by 3 by solving this triangle. Hope the concept is clear. Hope the numerical problem is also clear to you. I have used two properties over here. Now, next question is this. If sine of sine inverse 1 by 5 plus cos inverse x, this is equal to 1, find the value of x. Find the value of x. It's again a very simple sum. Just take this sine to the right hand side. Sine inverse 1 by 5 cos inverse 1 by x is sine inverse 1. Now sine inverse 1 by 5 plus cos inverse x is sine inverse 1. This is sine inverse sine of 90 degree. That is pi by 2. Only pi by 2 is left. Now take this cos inverse to right hand side. sine inverse 1 by 5 is pi by 2 minus cos inverse x. Now again use the property sine inverse x plus cos inverse x equals to pi by 2, or pi by 2 minus cos inverse x is sine inverse x. So I get sine inverse 1 by 5 is sine inverse x, or x equals to 1 upon 5. Right? Now with this I wind up the lecture number 3. I've done few questions depending upon the properties of the inverse trigonometric functions. In my next lecture, we will again try to solve problem sums depending upon the properties. Okay? Hope you revise those properties and just go through these problem sums which I have solved. Thank you. Thanks for watching my video. Keep working hard. Make your concepts clear. Thanks.